Hi, in this video we are going to see about a Python IEEE project which is entitled as Enhanced Breast Cancer Diagnosis Using Machine Learning on Patient Data and Deep Learning, which is an enhancement of IEEE base paper title toward improving breast cancer classification using an adaptive voting ensemble learning algorithm, which is an IEEE 2024 journal paper. So before seeing the execution of the project, let me brief about this project. So we all know about the breast cancer, the deadliest disease. So this breast cancer is a disease that grows in the human body through abnormal cells. So this affects both men and women, but mostly women are being affected. So there is a statistic that breast cancer cases that is calculated for the woman are 2,87,850 in 2022, and for the men which is around 2,710 cases. This is according to the American Cancer Society. So the death rate is also high in women. So death rate for men is 530, but for women is around 43,250. So for men or women, so this disease affects, and if it is being diagnosed in the early stage, so there are many chances of survival, and also it can be cured easily. So there are many types of breast cancers available. So in this base paper, the authors have used the machine learning model for identifying the breast cancer classification. So in this base paper, the authors have used the ensemble approach. So in this ensemble approach, they created voting ensemble classifier which combines 4 different machine learning models. That those are extra trees classifier, light gradient boosting machine learning, ridge classifier, and linear discriminant analysis. So these are the 4 different machine learning model that they are combined for the voting ensemble classifier, and they achieved 97.6%. So this is about the base paper. So kindly note that we are not going to implement the same as mentioned in the base paper. So now we are going to enhance from the base paper. So now let us see that what are the things that we are going to enhance from the base paper concept. So we are going to, from the title we could come to know that we are going to use both machine learning and the deep learning concept. In the base paper, they have used only the machine learning concept. They have used only the numerical data set. So here they have used WBCD dataset, that is Wisconsin Breast Cancer Diagnosis dataset they have used, and we are also going to use the same dataset for the machine learning part. And for the deep learning, the base paper does not uses any deep learning concept, but we are going to use the deep learning concept, and we are going to use histopathological images for the deep learning concept. So from the base paper they have achieved 97%. So now for the machine learning model, we are going to use 2 different models. The first model is stacking classifier, the second model is CatBoost classifier. So the first model, stacking classifier, are achieved the training accuracy score of 99% and test score of 94%, whereas the CatBoost classifier achieved the accuracy training score of 100% and test score of 98%. So for the first concept, we are implementing 2 different machine learning model, and one model, CatBoost classifier, achieves more accuracy than the existing system. And second part, we are going to use the images also, that is the histopathological images of the breast, and we are going to identify the classify whether it is a benign or malignant, which is cancerous or non-cancerous. So for that deep learning model, we are going to use DenseNet 201 architecture, and we have achieved training accuracy score of 98% and validation accuracy of 88%. So these are the things that is we are going to implement, that is enhanced from the base paper concept. So now let us see about the data set part. So the first thing, that the machine learning part, we are going to use this data set that is as mentioned in the base paper. We are going to use this the WBCD dataset, that is Wisconsin Breast Cancer Diagnosis dataset. So this dataset contains around 569 features, and here you can see dataset records. Sorry, it contains 569 dataset records, and the features parts, it contain around 32 features. So there are 32 features they are using. So here you can see the features like ID, diagnosis, radius mean, texture mean, perimeter mean, area mean, smoothness mean, compactness mean, concavity mean, concave point mean, symmetry mean, fractal dimension mean, radius, texture, perimeter, area, smoothness, compactness, concavity point, symmetry, fractal dimension, radius worst, text worst, perimeter worst, area worst, smoothness worst, compactness worst, concavity worst, concave point worst, symmetry worst, fractal dimension worst. So these are all the 32 features that we are going to use for the machine learning model, and the dataset record contain around 569 dataset record. This is about the machine learning part. And coming to the deep learning part, we are going to use this dataset. So this dataset which we are going to use is named as the break his 400 dataset. So this is the dataset that we are going to for the deep learning model. Here you can see the test and train cases of it. So in the test part, you can see there are two cases, benign and malignant. So here you can see the images of the benign case. So these are the things that is used for the test case. And for the malignant, you can see these are the images that we are going to use for the malignant part. So these are the few images of this breast cancer histopathical images. And for the train, you can see that for the test you can see the same for the benign and the malignant part. So this is about the data set that we are going to use for the deep learning part. So now let us see about in detail in the abstract document. So this is the project title, Enhanced Breast Cancer Diagnosis Using Machine Learning on Patient Data and Deep Learning. This is the IEEE base paper title, and this is the IEEE base paper abstract. So coming to our proposed abstract, so we are going to develop the Enhanced Breast Cancer Diagnosis Using Machine Learning on Patient Data and Deep Learning, so which is a dual modality diagnosis system that the patient data and the histopathological images analysis will be used. We are going to use in Python, and for the front end part we are using HTML, CSS and JavaScript, and we have developed using web framework Flask. So here those details have been mentioned. And coming to the first thing, that is the machine learning component, we are going to use the WBCD dataset, and here you can see the dataset record 569 dataset records and 32 diagnostic features. So those are the features, and the two models that we are going to train is a stacking classifier which achieved 99 accuracy, and for the training and the test we have achieved 94%, and CatBoost classifier which yielded 100% training accuracy and test score of 98%. So this is about the machine learning part. So in the parallelly in the deep learning model, we have applied DenseNet 2.1 architecture, and we have used the breast cancer histopathological images. So that is a breakis 400x data set. So it contains 1693 microscope images. So this is classified as malignant and benign. So here 371 benign and 777 malignant images used for the training set, and for the test set we have used 176 benign and 369 malignant images. So the DenseNet achieved 98 validation accuracy and 88 test accuracy, and those details have been summarized in this abstract. But coming to the existing system, so we are going to take the base paper as an existing system. So we are going to consider this base paper as existing system, and so those details of the existing system is being described, where they have used the 4 distinct machine learning model: extra tree classifier, light gradient boosting machine, ridge classifier, and the LDA, linear discriminant analysis. Though details have been mentioned, and the existing system does not use the deep learning part, so they have used only the machine learning part with the data sets of the features of WBCD dataset, and those details have been summarized in the existing part. And coming to the disadvantages of the existing system, you can see the first disadvantage that I mentioned is absence of the image based analysis. So they are not used histopathological images, and lower accuracy and reduced diagnostic sensitivity and specificity, risk of model bias and overfitting, lack of multimodal approach, and challenges with borderline and the complex cases. So these are all the things that is being described in the disadvantage of existing. So coming to the proposed system, so what are the things that is mentioned till now about the proposed system has been explained detailedly about the data set, the model, the stacking classifier, CatBoost, and the histopathical images based on the DenseNet part has been explained clearly. Those details have been detailed in the proposed system. And coming to the advantage of the proposed system, you can see the enhanced diagnostic accuracy. So we have achieved accuracy than the base paper, and also we have implemented the image based thing, the multi-model analysis, and we have used histopathical images, improved sensitivity and specificity, and reduction of false positive and negatives, real-time and user-friendly interface, scalability and flexibility, minimization of diagnostic bias, efficient data processing pipeline, potential of early detection and timely intervention. So these details have been summarized in the advantage of the proposed system. And coming to the system architecture, the machine learning model contains this input Wisconsin breast cancer data set as the input, and pre-processing feature selection is made, and we have applied the stacking classifier and CatBoost classifier, and the prediction result will be on benign or malignant, and finally the performance analysis and the graph part will be shown. And coming to the deep learning model, the input break is 400x data set images being given as the input, and pre-processing feature selection is made, and DenseNet 201 architecture has been implemented, and predicted result is benign or malignant. And finally the performance analysis and graph part is shown for this. So this is the system requirements, this is the minimum hardware requirements and the software requirements. So this project can be executed in Windows 10 or 11. The coding language that we use is Python 3.12.0. Web framework is Flask, and front-end part contains HTML, CSS, and the JavaScript. So this is the reference of the IEEE base paper whichever I have shown you. So now let us see the execution of the project. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of Python or the library installed in it. So now inside the source code folder, you can find this breast cancer. Inside that we have the app.py. So here in the address bar, let me type cmd and click enter. Now type python app.py and click enter, and kindly wait for a few minutes. Now you can see this URL. Just copy this URL. Go to any of your browser. I'm going to Google Chrome, paste it and click enter. So now you can see the project home screen or welcome screen with the project title, Enhanced Breast Cancer Diagnosis Using Machine Learning on Patient Data and Deep Learning. So now click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part. So first thing we are going to show is the deep learning part, which is the enhancement of the base paper. So first thing you can see breast cancer diagnosis using the deep learning. So here in the preview part, you need to upload the image of the histopathological images. So it will be predicting the case. So now let me select the choose file. So here in the project folder, we have the test data. Inside that we have the machine learning and the deep learning. The first thing is the deep learning. So let me go to the deep learning. So here I have given few cases with the benign and malignant. So now let us check with a random image, and then you can preview the image that we have selected, and then click the submit button. So now you can see the predicted result of it. So here you can see the image that we selected, and the predicted result is benign. So now if you want to check with the other case, just select the preview menu again. Now I'll just select an other image from the other case, malignant, and let me select an image, and then you can preview the image and click submit. So now you can see the predicted result. The predicted result is malignant. So now let me go to the preview menu. So this time I'll just select an image from the train data set. So let me go into the model folder. In the model folder we have this deep learning part. Here we have the images with the train. So let me select an image randomly. So you can see there are several images available. I'll just select a random image and click submit. So now you can see the predicted result is being classified as the benign. So similarly, I'll just select a image from the other case, the training part itself. So there are lots of images that is available for the malignant part also. So let me select an image. You can see the image and then click submit. So now you can see the predicted result is classified as the malignant. So in this way you can check with other cases for the both benign and malignant from the test and the train folder. So there are lots of images available, you can check with all the cases. Now let us move to the performance analysis part. So this is the performance analysis part for the deep learning part. So the performance analysis for the DenseNet 201 model. So here you can see the accuracy is 0.881, precision is 0.913, recall with 0.881, F measure with 0.881. And here you can see the confusion matrix for the DenseNet 201 model. So this is the confusion matrix with the true and predicted label for the both benign and malignant cases. And finally the chart part for the deep learning part. So this is the for the deep learning part, you can see the static visualization chart, which contains the distribution of the class of the malignant with 70% and benign with 70%, malignant with 30% from the data set that we have used. And now let us move to the machine learning part. So just click this breast cancer classification using machine learning. So this will be from this part we'll be seeing about the machine learning part. So now let us select, you can see the breast cancer diagnosis using the machine learning. Now let us select the data set. So now inside the source code folder, now go inside the source code folder. Inside that we have the breast cancer. Inside that we have this upload.csv file. So you need to select this file only. So just select this upload.csv file and then click the upload button. So now after uploading, it will be navigated to the preview part. So in the preview part, you can see the data set that we have uploaded, which contains all the features that whichever I have shown with the 569 data set records is being loaded into the preview part of it. So you can check all the data set which I've shown you with the features of it. Everything is being loaded into the preview part. Now in the bottom of the page, you can just select this click to train or test button and kindly wait for a few seconds. Now you can see the training finish message and click OK. So now it will be navigated to the important part, that is the prediction part. So here we need to enter the patient data, and here finally you can see before the predict button, you can see the model part where we are given you the stacking classifier and the CatBoost classifier in the drop down. So the user can select whichever the model they wanted. Accordingly the results will be predicted, the model results will be selected. I will be showing with the both the model cases now. So the first case I will give some values now. So the first case I have given these values: texture mean with 20.78, area mean with 519.4, concavity mean as 0.03136, area SES 34.78, concavity SES 0.01949, fractal dimension as 0.06087, smoothness versus 0.1297, concavity versus 0.08112, symmetry versus 0.3196, fractal dimension versus 0.06435. and let me select the stacking classifier and then click the predict button. So now you can see the result page. So in the result page, you can see what all the detail that we have entered is being shown in the input and the output parts. And finally you can see the model that we selected is stacking classifier, and the predicted result you can see it is being classified as benign. So benign means it is a non-cancerous. So now let me have the option. So the option of downloading this as a PDF. So just select this download PDF. So now you can export the result for, let me save it as one.pdf in the desktop. So you can just export the result for the future reference. You can just have this as a future reference. So now what I'm going to do, I'll just give the same values whatever given, and also I'll just I'm going to select the same values and just going to change the model as a CatBoost classifier and then click the predict button. So now you can see the result page with the same values whatever that we have given, and you can see the predicted result. It is also classified as benign only. So both the model is giving the same result. Let me export the result as 2.pdf, so you can just compare the results and you can check it out. So now let me check with the other case. Just click the prediction menu again. So for this case I have given these values, you can just check it out quickly, and let me select the model as stacking classifier and then click the predict button. So now you can see the predicted result with the value that we have entered, and here you can see the predicted result for this case is malignant. So malignant means it is a cancerous case, so it is a breast cancer case, and you can just export the result whatever I said you earlier in the same way. So now let me go to the prediction menu and show you a final case of it. And for the final case, I'm going to give these values quickly. You can just check it out, these values, and I've selected the model as CatBoost classifier, and then let me click the predict button. So now immediately you can see the predicted result with the values that we have entered, and finally you can see the model is CatBoost classifier and predicted result is malignant case. So now I have shown you 4 cases, 2 with benign and 2 with malignant, and one model, the 2 model with the CatBoost and the 2 model with the stacking classifier. So in this way you can check with the all other cases that is available, the test and the train data whichever given, and you can check out the results of varying inputs that you're going to give. And now let me go to the performance analysis part. So this is the performance analysis part for the machine learning part, so where we have used stacking classifier and the CatBoost. So now in the performance analysis part, first part you can see the stacking classifier performance analysis, which contains the class benign and malignant with the recall F1 and the precision value of it. And then comes the confusion matrix for the stacking classifier model with the true and the bitter label of it. And then comes the CatBoost classifier performance analysis with the class benign and malignant with the recall F1 and the precision values, and then shows the confusion matrix for the CatBoost classifier. So here in this performance analysis part, it contains about the machine learning model, stacking classifier, and the CatBoost whichever we have implemented. And finally can move to the chart part. So here you can see the static visualization chart for the machine learning part. So first chart shows the model accuracy comparison chart, which shows the model accuracy comparison for the both the stacking classifier and the CatBoost classifier, which shows the train accuracy of 99% for the stacking classifier and test accuracy of 94% for the stacking classifier. The CatBoost classifier contains train accuracy of 100% and test accuracy of 98%. And then comes the class distribution chart, which contains the 60% of malignant data and 40% of benign data. So this is the distribution chart that is shown from the data set that we have used. So here these two classes have been distributed like this. And then comes the box plot for the selected features chart. So here you can see the selected features that we have used as box plot for it, and then you can see the correlation heat map chart. So this is the correlation heat map for the features that were selected, and then comes the violin plot for the selected features chart. So these are the violin plot for it, and then finally the join plot for texture mean and the area mean chart. So this part is about the chart part for the machine learning part. And now let me log out, and before concluding, let me show you about the frequently asked questions. So these are the few of the frequently asked questions. So what is the main purpose of the project? So the primary purpose of this project to assess the healthcare professionals in early detection of breast cancer by using the advanced machine learning and the deep learning model. So this project combines both the numerical patient data and also the histopathological images. So this is the main purpose of the project. And second question, how does this project differ from the existing system? So in the existing system, they have used only the machine learning part, the numerical data part, but here we have integrated the numerical data part and also the histopathological images, deep learning part, and also we have improved the accuracy from the existing system. And which machine learning and deep learning models are used in this project? So in this project we have used stacking classifier and CatBoost for the machine learning, and for the deep learning we have used density architecture. And what are the accuracy that been achieved for the both the machine learning and deep learning? So stacking classifier with the 99 training accuracy and 94 test accuracy, and CatBoost with 100% training accuracy and 98 test accuracy, and Dataset contain 98 training accuracy and 88 validation accuracy for the histopathological images. So what data sets are used in this project? So in this project, for the machine learning part we have used WBCD data set, and for the deep learning part for the image data set we have used BreakHis 400x data set. And how does the system ensure the accuracy of the project? So the system employs the high performance model including Dataset, the deep learning, and ensemble like stacking and the CatBoost for the machine learning, so which ensures the accuracy of the predictions. So is this the system intended to replace the radiologist and the pathologist? No, this system is not designed to replace the medical profession. It is intended to act as a diagnostic aid providing healthcare profession with a second opinion that can assist in making more accurate and the faster diagnostic decisions. And then what are the primary components of the system architecture? The primary component in the backend, we have used Python with web framework as Flask, frontend pattern HTML, CSS, JavaScript. Machine learning model, we have used tagging classifier, CatBoost classifier, deep learning model with the DenseNet 201. And can this system can be deployed in real world healthcare environment? Yes, the system can be deployed in the real time scenarios. What are the benefits of using both machine learning and the deep learning for this diagnosis system? So combining both the machine learning and deep learning, that is histopathical images, has various advantages, so that the dual approach can lead improved diagnostic accuracy and provide more comprehensive assessment of it. So these are all the few frequently asked questions, and this is all about the project enhanced breast cancer diagnosis using machine learning on patient data and deep learning. And thank you for watching.